Hello, class. Well, guess what? I'm not here today. However, we're still going to learn some stuff. I know you're excited. Settle down. Anyway, we're gonna learn about solutions. We're gonna learn about these in order to understand acids and bases, which is actually going to be next chapter. But in order to do that next chapter, we need to know about solutions. So let's move on. First off, we need to talk about concentration. No, I know you're supposed to concentrate during a test. This is different. So concentration, it's the measure of the amount of dissolved solute per unit of solvent. Let's take a look. Here we've got some maple sap as well as some orange juice. Both of these things I would consider dilute, which means there's not a whole lot of solute in them, which we had talked about before. That's the thing that's getting dissolved per unit of solvent. Whereas, if we want them to be concentrated, what we need to do is we need to remove some of the solvent. So there would be a lot higher concentration of solute. So in this case, you could actually use an evaporator, and the evaporator removes a bunch of the water from maple sap and turns it into maple syrup. Same thing down here. There's evaporators that you can use to actually take a lot of the water out of orange juice, and it turns it into orange juice concentrate. A lot of people think, oh, it's not real orange juice, it's from concentrate. It's real orange juice. They just take the water out of it. Makes it a little bit easier for shipping and whatever. And then you add water back to it. So that's orange juice from concentrate. And here's a video. Oh, there it is. Just put myself in the way. I think it's like 3.5 minutes or whatever. But it's a sugar shack, and what they're doing is they're evaporating the solvent, which would be the water, in order to create a higher concentration of solute, which would be the sugar, in order to make maple syrup in Canada. Eh? Okay. Next, solutions. Concentration. The greater concentration, the greater density of the solution. Well, that makes sense. If there's a higher concentration, if there's a whole lot more salt in salt water, it's going to be more dense. Here's what I mean. Like in the Dead Sea. The Dead Sea, the water there is very dense. It's a lot more dense than, let's say, fresh water. And since the water in the Dead Sea is a lot more dense, you can float in it significantly easier. Fresh water, like in Lake Erie, is a lot less dense because it has a lot less solute in it. More solute, more salt, more dense. Less solute, less dense. In fact, I think in the previous video, one of the guys that was showing you around the sugar shack, he had a tool that you put in the liquid, and it sees how high that tool floats. So therefore, if you were to put that tool, that little floater thing, I think it's a hydrometer, you put it in this water, it would float higher, whereas if you put it in fresh water, it floats lower. Same thing with you. You put yourself in salt water, you float higher in the salt water. You put yourself in fresh water, you float lower. And I think I demonstrated that once before by floating an egg in salt water in class, and then putting the egg in fresh water, and it sinks to the bottom. Anyway, here's like a 38-second video of floating in the Dead Sea. We're going to pause for a second so you can watch that video. Okay, unpause. Let's move on to the next slide. It's just a fun video to watch. Okay, let's talk more about solutions. So there's something called solubility. It's the measure of how much solute can dissolve in a solvent at a given temperature. So think about this here for a second. Like, how much sugar could you put into 100 grams of water? So how many grams of sugar can you put in there? Could you put 50 grams of sugar in 100 grams of water and stir it up and dissolve it all? Could you do that with 75 grams of sugar? How about 100 grams of sugar? Well, I'll give you a hint. It's more than 200 grams of sugar you can put in 100 grams of water. You can dissolve a lot of sugar in water. A lot. But how does the temperature affect this? How much solute can dissolve? So think about this here for a second. How could you dissolve more sugar in that water? Well, if you heat it up, you can. You ever make Jell-O before? If you've made Jell-O, you actually have to heat up the water so you can cram even more solvent in there, or more solute in there. So the temperature changes how much solute you can actually fit. Here's a chart that shows you exactly what I'm talking about. Here's all these different substances. Let's take one we're familiar with, salt. Right around freezing, just above freezing, if you had water that's right around freezing, you can actually dissolve about 35 grams of salt in it. So there's 35 grams of salt you can put in there. Now let's heat that water up almost all the way up to boiling. And once we heat it almost all the way up to boiling, now we can dissolve 40 grams of salt in there. Ooh. But look at the pattern of almost all these things. The hotter the water gets, the more you can dissolve. So you heat it up and you can dissolve more stuff in there. But if you cool it off, you can dissolve less stuff. Unless you're talking about this cerium stuff. You're just not going to dissolve as much of that in there. That's the only thing I know of that actually you can dissolve less of it as it warms up. Almost everything else you can dissolve more of it whenever you heat it up. Anyway, let's talk about a saturated solution. A saturated solution is a solution in which no more solute can be dissolved. Think of it like a sponge. With a sponge, you can put water in a sponge. And you can put more water in the sponge. You can put more water in the sponge. But there comes a point at which the sponge is completely soaking wet and you just can't put more water in. You just can't do it. At that point, the sponge is completely saturated. Well, it's the same thing with solutions. With solutions, let's take our salt for example. We can fit 35 grams of salt into 100 grams of water, keep in mind, right around freezing. If we raise the temperature, then we can put 40 grams of salt in there. But let's pretend it's right around freezing. You can fit 35 grams of salt in there, and that would be the saturation point. You just can't put more salt in there. You just can't do it unless you heat it up. So that would be the saturation point. So different substances have different saturation points in water. So if you put more than 35 grams of salt, it won't dissolve. You can stir and stir and stir and stir. It's not going to matter. You just can't dissolve any more in there. That is the saturation point. That's when you have a saturated solution. Anyway, there's a table for a solubility table. You know, it's just a picture of that. So, you know, you can skip that actually. Let's move on. Okay. Remember how I said you can only fit a certain amount in there? Well, I just lied to you just a little while ago. Technically, you can fit even a little bit more. It's a supersaturated solution. So a supersaturated solution is a solution that contains more solute than a saturated solution. Remember how I said that you can fit 35 grams of salt in water that's cold, but you can fit 40 grams of salt in water that's hot? Let's pretendsies here for a second. Let's pretend the water's boiling. I put my 40 grams of salt in there and I stir it up. Good. Now I cool that water back down to almost freezing. At that point, now it is actually super saturated because I put 40 grams of salt, which I'm not allowed to do, in cold water. But what I did was I heated it up first and then I cooled it down, and now it's technically super saturated. So it says, suppose the solution is saturated 100 degrees Celsius, kind of like our water. We put 40 grams of salt in it. It's saturated. When that solution cools down, it has more solute than it should be able to hold. Now it is super saturated. Here's a video. Go ahead and click this video, and it's of a supersaturated solution and how you can actually get that supersaturated solution in order to solidify. Anyway, we'll pause here for a second. Take a look at this video. Okay, pause over. Anyway, maybe you noticed in that video that the supersaturated solution actually got hot. So there's this, it's not a phenomenon, it's the same thing that happens in chemical reactions, which making solutions is often a chemical reaction. You can have a chemical reaction or making a solution that is exothermic. The formation of some solutions are exothermic, which means they give off heat. they get hotter. Unfortunately, it's showing the endothermic, so we'll go backwards here. So in an exothermic reaction, energy is released into the surrounding as heat. As a result, the temperature of the surrounding increases. So an exothermic chemical reaction would be like an explosion or something like that. Well, in the previous video that you just watched, it was an exothermic chemical reaction, and where they, I think it's sodium acetate or something like that, or is it potassium acetate? No, sodium acetate. Anyway, with that, this is a very similar video, and we'll pause here for a second, but they'll talk about how it's an exothermic video. I think it's about 2 minutes, so let's pause. Okay, we're back. So now we've got an endothermic chemical reaction. Endothermic means to take in heat. Instead of giving off heat, it actually gets colder. So it's the formation of some solutions are endothermic. They take in heat and they get colder. Maybe you've seen some of those, like those ice packs sometimes at gyms. I'm not talking about the ice pack you have to put into a freezer. That's not what I'm talking about. I'm talking about an ice pack that's room temperature. You twist it, you mix these two chemicals, and there's an endothermic chemical reaction. And then it gets cold as ice without you having to put it in the freezer, because that's an endothermic chemical reaction. Let's pause here for a second so you can watch the endothermic chemical reaction video. Okay, we're done with that. Let's move on. Let's talk about the solubility of gases. There's different factors that affect how much gas you can actually dissolve inside a liquid. That first factor is pressure. Larger amounts of carbon dioxide can be dissolved into soda at higher pressure. When the bottle is open, carbon dioxide is no longer dissolved. Maybe you've noticed this before. You've had a clear bottle of Sprite or something like that. You don't shake it or anything like that, but as soon as you open it, all these bubbles form. Well, guess what? Before you opened it, it was under high pressure, so you could put lots of carbon dioxide in there. Once you open it, it's got low pressure, so that means the carbon dioxide can't be dissolved in there anymore. So it all comes down to pressure and temperature. The second factor is temperature. Gases can be dissolved more easily at lower temperature liquids than at higher temperature liquids. This sounds actually kind of backwards. It's the opposite of dissolving solids. Whenever you're trying to dissolve a gas in a liquid, the colder the liquid is, the better the gas can dissolve. Which I know we said that's completely opposite of solids. So think about it this way. Would you rather open a warm can of root beer or a cold can of root beer? And you're probably thinking, well, cold can. The warm can, all that carbon dioxide actually comes out of the solution when the root beer is warm. But when the root beer is cold, it holds more of the carbon dioxide in. It's the same thing in the ocean. Why is there a greater concentration of ocean life? Where would you find it, in Alaska or Florida? And a lot of people think, oh, Florida, I've been there before. No, no, no. You'll find a lot more ocean life in Alaska. And the reason why that is because the water is colder. And since the water is colder, you can dissolve more oxygen in the water. So colder water dissolves more oxygen. Think about it this way. Maybe you've had a fish tank at home. And for some reason, if you've left the heater on in the fish tank and the heater goes way high up and it's just too hot, all the oxygen in the fish tank is actually going to come out of the fish tank because warm water doesn't hold much gases. Therefore, all your fish are going to die. You'd actually have better luck keeping the temperature of the fish tank cooler, and therefore more oxygen can go in there. Here's a fun video that you should go ahead and watch, and it's all about the solubility of gases. Someone's going to prove my point by opening a warm can of soda, a cold can of soda, and then a room temperature can of soda. Anyway, we'll pause for that, and actually this is the end of the video. So have a great day. Watch that video, and I think I might have a worksheet for you after this. Well, have a great day. Hope to see you tomorrow.